Hello everyone, I am back again. Today we are going to be looking at how to represent inequalities on a Cartesian plane. In our last video we discussed how we represent these inequalities on a number line, how we solve simple linear inequalities, and now we are going to look at Cartesian plane. So if you have not watched that video, I advise you go and watch it so that you give you a background of what we are going to do now. So these are inequalities except this first one that is an equation. How do we represent it in a Cartesian plane? A Cartesian plane is a two-dimensional graphing of coordinates of points where we use x and y to represent. X represents the horizontal axis where y represents the vertical axis. So let's just begin immediately. For this first one, they said x equals 3. So if we are just going to represent that on a Cartesian plane where we have the vertical axis labeled y and the horizontal axis labeled x, and then we have the scaling of 1, 2, 3, 4, maybe minus 1, maybe here we have 1, 2, 3, and so on and so forth. But they said x equals 3. What it simply means is that at x you have 3, you draw a line on that tree. This is x equals 3. And that is it. How to represent on a Cartesian plane. Then, this is for equation. Then when we come to inequalities, you have x greater than or equal to minus 1. X greater than or equal to minus 1. Now, let's see how that is going to be represented on a Cartesian plane. This is x, this is y. So you locate minus 1. Locate minus 1, then you draw a line on minus 1 using your ruler. Remember, you draw a straight line on minus 1. Then what do we do? It is greater than. From minus 1 towards the right, to the right is greater than, to the left is less. So since it is greater than, we are going to shade to the right. This way, we're going to shade to the right. And this is how we represent x greater than or equal to minus 1 on a Cartesian plane. Very simple as that. Let's look at another one. We have the second one, x is less than 2. So let's see that. We have y here. We have x here, we have 1, we have 2, probably 3, maybe minus 1, minus 2. You can write as much as you want or as you have the need. So we have x is less than 2. So we go to 2 and draw a line on 2. And then, because this is less than, it doesn't have equal to, this line is going to be a broken line to indicate that it's not equal to like the first one. This is just less than. So because of that, it is a broken line. And less than is to the left, while greater than is to the right for x. So we are going to shade to the left. This is how we represent on a Cartesian plane. You can see that. So this one also said y is greater than 4. Okay, this time around is y. So if we have this y, we have this x, and we have 1, 2, 3, 4, 5, maybe minus 1, minus 2, 1, 2, 3. I said as much as you can. So an y is greater than 4. So it is on y that we are going to draw the line on 4, greater than 4. And remember I said because there is no equal to it is just greater than, this line is going to be a broken line. Then greater than 4, greater than on the vertical is above, because you can see as it is increasing up and decreasing down. So greater than should be above and less than should be below. So since it is y greater than 4, we shade up. So this is the region on the Cartesian plane that satisfies this inequality. Do you see that? So then finally, y is less than or equal to minus 3. If this is minus 3, we have minus 4. We go to minus 3 on y and draw a line. Then, because it's less than or equal to, it's going to be a continuous line, not a broken one. Less than is down, greater than is up, and this is less than or equal to, so we shade down. So that is how you represent inequality on a Cartesian plane. So if we are to represent this inequality on a Cartesian plane, I said what we will do first is to say at x equals 0, what will be y will be equal to, we write this as an equation, that is y equals 4 minus x. So at x equals 0, y will be equal to 4 minus 0. That means y equals 4. And we have a coordinate 0, 4. Then you take at y equals 0, and then if you substitute y as 0 in this equation, you have 0 equals 4 minus x. And when x crosses, x will be equal to 4. So we have a coordinate 4, 0. So this is what we have. Then when you draw your Cartesian plane, carrying the y and the x, and then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Minus 1, minus 2, it might not be needed. Okay, so at x equals 0, y is 4, you go to y4 and locate that point. At y equals 0, x is 4, you go to x4, locate that point, and join the 2 points. Now, what will determine whether it is going to be a broken line or a continuous line is if the inequality sign has equality on it. This is greater than, there is no equality on it, so it is going to be a broken line. If it is greater than or equal to, that is when it will be a continuous line. So as we've drawn this line, this is the boundary between the up and the down. We have two regions now, dividing this Cartesian into two regions, up and down. So to check the correctness, whether we are going to shade up and down or down, we'll check, let's locate a point that is within this region and a point within this region. I can locate a point here. Maybe I say 1 against 1. This point is within this region. So when x is 1 and y is 1, let's check. If I put x as 1 and y as 1, this place is 1. That will be 1 greater than 4 minus 1. Is 1 greater than 3? 4 minus 1 is 3. No. So this is not correct. Let me try another one. I know already that this place is not correct, but let us just still try and confirm. Let's check this point. When x is 1 and y is 2. Okay? When x is 1 and y is 2, if you put y as 2 greater than 4 minus 1, okay? 2 greater than 4 minus 1 is 3. Is 2 greater than 3? No. So this region is wrong. I don't even need to confirm, but let us still confirm. If I check this place, let's say 3 against 4, okay? This point now is 3 against 4, and this point is up. So when x is 3, y is 4. So let's substitute y as 4 greater than 4 minus 3. 4 greater than 4 minus 3 is 1. 4 is greater than 1, so this is correct. So we shade this region. That's exactly how easily we can locate where to shade. You can see that. That is how you do that in inequality. We'll try one more. Okay, let us look at this one again. I said the first thing you do is to write it as if it was an equation equals 4x plus 3y equals 2. Then you see at x equals 0, what will be y? You have 4 times 0 plus 3y equals 12. 4 times 0 is 0, then 3y is equal to 12. That means y is 12 over 3, which is 4. So at x equals 0, y is 4. Then you check at y equals 0, what will be x? So we have 4x plus 3 times 0 equals 12. 3 times 0 is 0, so 4x is 12. And that means that x is 12 over 4, which is 3. So the point will be at y equals 0, x is 3. So these are the 2 points we have, 0, 4 and 3, 0. Then on a Cartesian plane, we have y, we have x. So we have 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5. So I locate at x equals 0, y is 4. I'll locate 4 on y. And then at y equals 0, x is 3. I'll locate 3 on x. Then join the 2 points. And I said what will determine whether it is going to be a broken line or a continuous line is if this inequality sign has equality in it. This one does not have equality, so it is going to be a broken line. Okay, then we'll choose any point in this region, any point in this other region to know which region will be true. Let us check this point here to here is still within this region. So if I locate this point when x is 1, y is 2. So let's substitute that and see. When x is 1, that is 4 times 1 plus 3 times 2 is it less than 12. 4 times 1 is 4. 3 times 2 is 6. Is it less than 12? 6 plus 4 is 10. Is it less than 12? Yes, 10 is less than 12. So this region has already satisfied. But let us confirm using any point in this other region. I can use 2 and 3. 2 and 3 is already up. It's no longer in this region. We are looking at the region that this line divides, up and down. So at x equals 2, y is 3. So we substitute 4 times 2 plus 3 times 3. Is it less than 12? Okay, 4 times 2 is 8. 3 times 3 is 9. 8 plus 9, is it less than 12? 8 plus 9 is 17. Is it less than 12? No, 17 is not less than 12. So this region is wrong. So this is where we will shade this time around. It is as simple as that, how to locate where to shade on a Cartesian plane for an inequality. Okay? Okay, what if we have more than one inequalities to be represented on the same Cartesian plane? Like we have here, we have 3 inequalities here of 2 variables. 2x plus 3y less than 6, y minus 2x less than or equal to 2, and y greater than or equal to 0. How are we going to represent this on a Cartesian plane? Let us see how that is done. We will do the same thing, solve for this, and solve for this to get the coordinates of the points. So we assume this to be an equation where we say 2x plus 3y equals 6, and at x equals 0 we have what? 2 times 0 plus 3y equals 6. That means y is 6 over 3, and that is 2. Y is 2. So we have 0, 2. Then at y equals 0, we are going to have 2x plus 3 times 0 equals 6. That means 2x equals 6, and x is 6 over 2, that is 3. So we are going to have 3, 0. Then for this other one, the same thing, y minus 2x to be equal to 2. We assume it's an equation and say at x equals 0. That means y, this will be 0, so y is equal to 2. So we have 0, 2. At y equals 0, if we substitute 0 here, we have 0 minus 2x equals 2. That means minus 2x equals 2. And x will be equal to 2 over minus 2. That means x is minus 1. So the coordinates of this other one will be x minus 1 and y 0. So we have this and this. Then this one is already here. It's just y. It doesn't have x. So we are now going to represent on a Cartesian plane. Permit me to claim this one is 0, 2, and 3, 0. So we are just going to remember the coordinates. We have 0, 2, and 3, 0 for this other one. Then this one will have 0, 2, and 1, minus 1, 0. 0, 2, minus 1, 0. So you have 0, 2, and minus 1, 0. How do we represent on a Cartesian plane? Let's draw a Cartesian plane. Remember, this is usually done in a graph sheet. Y, x, here is minus y, x, here is minus y. So I have 1, I have 2, I have 3, I have 4, I have 5, I have minus 1, minus 2, minus 3, 1, 2, 3, 4, minus 1, minus 2, minus 3. Okay, so this is at x equals 0, y is 2. So you go to y and locate 2. At y equals 0, x is 3. Go to x and locate 3. Then join the 2 points. And what will determine whether it's continuous or broken line is the inequality sign. Because there is no equality sign on it, it is going to be a broken line, as we agreed. A broken line. Of course, because we have more than one inequalities, you label it. This one is for 2x plus 3y less than 0 less than 6, sorry. 3 and at x equals 0, y is 2. You go to y and locate 2. And at y equals 0, x is minus 1. Go to x, this is x, locate minus 1. Then you join the 2 points. Because this inequality sign has equality in it, we use a continuous line, not a broken line. Remember, you use ruler to do that. And we are going to label it as y minus 2x less than or equal to 2, because this is the inequality that gave us this coordinates. Consider. Then the third one is y greater than or equal to 0. You remember how we represent a single variable on a Cartesian plane. So we just go to y at 0. This is 0 for y. This is 1 for y. This is 2 for y. This is 3 for y. 4 for y. So this is where the 0 is. Because it's greater than or equal to, it is not going to be a broken line. It's a continuous line. So it is on this line. So we are not drawing any other line. We can label here our y greater than or equal to 0. Then where are we going to shade? So what I'm going to do now is to shade the region, any region that appeared that is existing in all the inequalities is what we are going to shade. Yes, any region that is existing in all the inequalities is what we are going to shade. So let us look at this one for the first. Take this one first. In this one, region below, it has down and up. So down, if I decide to take 1 against 1, is below for this line. So 1 against 1. If I substitute 1, 1 here, 2 times 1 is 2, 3 times 1 is 3, 2 plus 3 is 5. Is 5 less than 6? Yes. So for this line, I'm going to shade below. Everything from here down. So this one is gotten. Then for this other line, if I check up or down here, since this is below, let me check below also for this. This point now, I can use this same point is in this region. And then we have another region here. I have 1 against 1. If I substitute 1 here and 1 here, I have 1 minus 2 times 1 is 2. So I have 1 minus 2 is minus 1. Is minus 1 less than 2? Yes. So this region is going to be shaded. You see, I have shaded this the first time and shaded this the second time. So this place is out, even though I shaded it here the first time. But because in the second shading it was not shaded, it's out. Even this place is out, even though I shaded it for this line. But because I didn't shade it for this line, it is also out. So what I have now is here and here. That is this place. Okay? Then for the third line, I have up or down. That is for y greater than or equal to 0. Then greater than or equal to 0, is it up or down? Greater for y is up. Less than is down. So greater is up. And if I shade up, you can see that this place is out because this place is no longer shaded in this third one. But this particular region was shaded in all. When I was shading here, this place was shaded. When I was shading for this line down, this place was shaded. Then when I was shading for this up, this was also shaded. So this is the region that satisfied the 3 inequalities. That is how we have gotten that. That's how we get that. Okay?